Okay, gentlemen, now we are at chapter 7, page 13 of your notes. Okay, in this part of the chapter, we are looking at the integration, involving such expressions over here. Okay, and we realize that what we need is actually a logarithm, for the integration. Okay, so at this point, I want you to take note that the power of the expression in the denominator is only power 1. Only when it is power 1, then you may use a logarithm. So if you, let's say, integrate a term like this, 1 over x squared, where the power is 2, what you actually learned earlier is that you can bring this to x to the power minus 2, and then what we get is actually negative x to the power minus 1 plus c. And what we get is equals to negative 1 over x plus c, and that is your final answer. So that is the case for when x has a power of 2. But if x has a power of 1, so you have to integrate 1 over x dx. Straight away you can only use logarithm. Alright, like this. For this expression, it is just a continuation of the previous one. But however, the denominator over here has a linear expression like this, ax plus b. So as a result, you need to multiply 1 over a to remove the effects of chain rule. At this point, I want you to look at this modulus sign over here. So the reason why there is a modulus over here, it is to make sure that this value will always be positive, because the logarithmic function can only take in positive values. So basically this modulus is just to make sure that this value here will become positive. This is required because initially the values of x can be any value. So this is basically to restrict this value here within the logarithm is always positive. So now we'll look at question number 1 to integrate 3 over 4x minus 1. So we have 3 over 4x minus 1 dx, and what we get is 3. 1 over 4x minus 1 dx, and finally we just simply have 1 quarter ln modulus 4x minus 1 whose modulus plus c. And what we get is 3 quarter ln mod 4x minus 1 plus c, and we are done. So for page 14, if you look at this question here, the first part requires you to express it as a partial fractions. The reason being that you won't be able to integrate this immediately. So to convert this to partial fractions, so we have 4 over x minus 1, x plus 3, equals to a over x minus 1 plus b over x plus 3. And we have equals to a x plus 3 plus b x minus 1 over x minus 1 x plus 3. So if you use the suitable substitution, substitute x equals to minus 3, we have 4 equals to a minus 3 plus 3 plus b minus 3 minus 1. What we get is actually b equals to negative 1. Alright, so the next part is to sub x equals to 1. Alright, and what we get is 4 equals to a 1 plus 3 plus b 0. And then what we get is simply a equals to 1. So as a result, this will give us equals to 1 over x minus 1 plus negative 1 over x plus 3, which is simply 1 over x minus 1 minus 1 over x plus 3. So right now we'll integrate this entire expression. We have integration okay, of 1 over x minus 1 minus 1 over x plus 3, okay, dx, and this will give us integration minus 1 over x plus 3 dx, and this will give us ln mod x minus 1 minus ln mod x plus 3 plus c. Okay, notice that you do not need to divide by a certain number in front here, okay, because when you differentiate x minus 1, x plus 3, the result is actually 1. So basically there will be no values in front. Okay, and that's all for this question.